Hi dear students, as part of MSET, NEET and other competitive exam preparation, I am uploading the different type of problems in my channel. Problems and their solution and the concept related to the topics. So that's why you have to subscribe my channel and press the bell icon too to get the all notifications. So up to examinations I will upload all the videos continuously. That's why you can follow my channel. Okay, in this video we are going to discuss about the some problems regarding the Kirchhoff laws and the potential difference between 2 points in a electrical circuit. Children, this is the third video, I think so. I already give the remaining videos in the playlist. That's why you can watch it. So without late, we are going to the topic. Here there is one question is there. The potential drop across the 3 ohm resistor is options 1 volt, 1.5 volts, 2 volts and D is the 3 volts. Dear students, this is the circuit diagram. Here in that one, 3 resistors are there. 3 resistors are available. One is 4 ohm, 3 ohm and 6 ohm and it is given to the battery 3 volts. What we have to calculate? We have to calculate the potential difference. That is what? Across. So across the 3 ohm resistor, we have to find out the potential difference. So dear students, so I am giving like this. This is the R3 and this is the R1 and now this is the R2. Children, here what we know, potential difference formula is what? V is equals to IR. V is equals to IR. Here the amount of current in the circuit is I and R is what? Effective resistance. Effective resistance in the combination. So that's why first we have to find out the what is the effective resistance and what is the current in the circuit. For that you can observe the R1 and R2. How these two are? R1 and R2 are in parallel. How they are? In parallel. That's why here I am going to write 1 by R is equals to 1 by R1 plus 1 by R2, some whatever Rx. 1 by Rx is equals to 1 by R1 plus 1 by R2. What is the value of R1? 1 by 6. What is the value of S? That is 3. R2 value is 3. Now 1 by Rx is equals to 1 by 6 plus 1 by 3. So now go for LCM. 6, 3. So 3 2s are 3 1s are. So LCM is 6. So 1 by Rx is equals to what? 6. 6 1s are and 3 2s are. Then what do you get? 1 by Rx is equals to 3 by 6. 3 by 6. Then Rx means what? 6 by 3 children. Then Rx is equals to what? 2. Rx is 2. Now this Rx is the effective of R1 and R2 is what? Rx. This Rx is in series with the R3. Rx is in series with the R3. So that's why here Rx is in series with the R3. So then what write? I am going to write R is equals to Rx plus R3. This is the formula for effective resistance in the series combination. That's what children, what write? R is equals to Rx value, how much you got? 2 and R3 value is what? 4. So therefore R is equals to what? Yes, 2 plus 4, 6 ohms. So R is equals to 6 ohms. So this is the effective resistance in the entire circuit. Effective or total resistance in the entire circuit is what children? 6 ohms. So that's why here simply now we want to find out the current. I is equals to V by R. So what is the V value? What potential of it is? 3 volts. And what is the R value? Yes, 6. Then 3 by 6 is what? 1 by 2. 1 by 2 is equals to what? 0.5 amperes. I value is what? 0.5 amperes. So current we got. Now we want to find out the potential difference between the across the R2. Across the R2 we have to find out. So now here potential difference between or across R2. So across the R2, what did you write, children? Formula what it is? Yes, V2 is equals to I of R by S. R by R2 we got. So V2 is equals to what? I means 0.5. I is what? 0.5, children. And R value is how much? 6. And R2 is what? S, 3. Therefore V2 is equals to 0.5 into 2. That is what, got, children? So here V2 is equals to 0.5 into 2 means what? 1 volt. So V2 is what, children? 1 volt. So in this way we can find out, children. So here in the question he was asked about the potential difference across the 3 ohm resistor. That's why what we wrote, V2 is equals to I into R by R2 we wrote. For example, he was asked about the 6 ohms, then what, right? V1 is equals to I by R of R1. So you have to write the effective resistance in the numerator, and we have to substitute the concerned resistor value of resistance value of resistor in the denominator. So this is the formula you have to remember. So to do this formula, to this problem, we have to use the 3 rules. First is what? Series combination of parallel combination of resistors. Next one is what? Series combination of resistors. And third one is what? Current formula. And fifth one is potential. So when we have idea about all these formulas only, it is possible, otherwise it is not possible to solve. That's why, children, among the 4 options, A option is the right one, children. See the next question, children. This is the one logical question and important model too. Watch very carefully. For the network shown in the figure, the value of the current is. So this is the one circuit diagram was given. We want to find out the current in that circuit. That is the given question, children. And some options are given. First option is 9V by 35. Second option is 5V by 18. And third option is 5V by 9. And D option is 18V by 5. So dear students, here you have to observe how it is there. Here how many resistors are there, here you have to check it. And now you have to observe this 4 ohms, 2 ohms and 3 ohms and 6 ohms. The arrangement of the resistors is quite similar to the arrangement of resistors in the width and width. That's why here what we have to say, here there is no current passes through the 4 ohm resistor, because it is quite similar to the galvanometer resistance in the diagram. Clear? So here there is no current passes through the 4 ohm resistor. There is only current passes through the 4 ohm, 2 ohm, 3 ohm and 6 ohm. Clear? So that's why here how we can find out the current, first thing we have to discuss it. For example, I am saying this is now R1 and this is R2 and this is R3 and this is R4, children. Now this R1 and R2, how these two are? How these are? S. So these are the in series. That's why here the effective of R1 and R2 I am going to write Rx, that is the R1 plus R2. So then Rx is what? 6 plus and 3. Therefore Rx is 9 ohms. And similarly here that R3 and R4 also in series. That's why the effective resistance I am going to take, that is Ry. Ry is equals to R3 plus R4, children. Now here R3 plus R4 means what? 2 plus 4, 6. 2 plus 4, 6 ohms. Clear? So Rx is 9 ohms and Ry is what? 6 ohm. Again these two are in parallel. Rx and Ry are in parallel. So when they are in parallel, how we can find out the value of resistance? So let's go for that. Here I need some space. Here simply I am going to write Rx is what? Rx is 9 ohms and Ry is what? 3 plus 2, 5. Ry is what? 2 plus 4. R3 plus R4, that is what? 2 plus 4, 6 ohms. That's why here now what I am telling, this Rx and Ry, how these two are? Yes, in parallel. Then I am going to write 1 by R is equals to 1 by Rx plus 1 by Ry. So here 1 by R is equals to 1 by Rx value is what, children? 9 ohms. 1 by 9 plus 1 by 6. So 9, 6. 3 3s are 3 2s are. Yes, 3 3s are 9 and 2, 18. So 1 by R is equals to what, right? 18. So 9 2s are and 6 3s are. So 5 by 18. So children, what we got? 1 by R is equals to 5 by 18 we got. So from that what, right? R is equals to 18 by 5. 18 by 5. Clear? Now what you have to find out, children? We want to find out the current. We want to find out the current. What we know? V is equals to IR. The I is equals to what, children? V by R. And what he was given potential? V. So I is equals to V by, what is the value of R? What it is? S. So what it is? 18 by 5. Then what you get? I is equals to 5V by 18, children. I is equals to 5V by 18. So in this way we can find out the amount of current in the circuit. Okay. So given options, among the given options, second option is the right one, children. See the next question, children. This is the another type of problem. Look here. The magnitude and direction of the current in the circuit shown will be. The magnitude and direction of the current in the circuit shown will be. So this is the one circuit is given. In that two cells are there. One is 10 volts and next one is 4 volts. And resistors are small. Internal resistance of the first one is 1 ohm and internal resistance of the second cell is 2 ohms. And this is the external resistance 3 ohms. So options are given, children, here. One is 7/3 A from A to B, 7/3 ampere from B to E, 1 ampere B to E, 1 ampere from A to E. So here in this diagram, this dot is the E. So now we want to find out the current and we have to identify the direction also current. Either it is A to E or E to B. A to E or B to E. A to E or B to E. We have to find out the direction also. So children, in this case you have to apply the Kirchhoff's second law. So that is the one of the option, and we have another option also there. That is directly we have to find out the current by using the formula. What we know, V is equals to IR. I is equals to what? V by R. In this case, I is equals to total EMF or total current voltage by total resistance. Total resistance. Clear? Now, what is total EMF here? This is the 10 volts and this is the 4 volts. You have to observe here polarities. Their order is different. Here it is lower and this is the higher potential. This is the higher and this is the lower. Their arrangement should be different. That's why here in this case we will take, this is the V1 I am saying, this is the V2. Now we have to write V1 minus V2 because V1 is greater than V2. And by total resistance I am saying now this is the R1 and this is R2 and this is R. Then what, write R plus R1 plus R2. Then I is equals to, what is V1? 10. What is V2? 4. 10 minus 4 volts by and 3 ohms plus 2 plus 1. So I is equals to what? 10 minus 4? 6. 3 plus 2 plus 1? 6. That means I is equals to 1 ampere. I is equals to 1 ampere. So dear students, so magnitude is came. Then how we can identify the direction? How we can identify the direction? So children, what we know, according to the conventional current, the current is always moves from higher potential to the lower potential. Higher potential to the lower potential. That's why here V1 is greater than V2 and the current should be moves like this. Clear? So the current direction should be here. A to E is the right one, children. That's why here what you have to say, the magnitude is 1 ampere and direction of current is what? A to E. That's why D option is the right one, children. Dear students, there are two bits, important bits are there. Just watch it here. Kirchhoff first law or Kirchhoff first law, that is sum of I is equals to 0 based on the law of conservation of. Kirchhoff first law is summation of I is equals to 0 based on the law of conservation of. Options are given: conservation of charge, conservation of energy, conservation of momentum, and conservation of angular momentum. So for that, these two are the irrelated. D and C are irrelated. Here there is some possibility for now charge and energy. Charge and energy. So what is Kirchhoff first law? The amount of current enter into equals to the amount of current leaving. Clear? The amount of currents enter into the, yes, I am showing like this. So here I1, I3, I4 enter and I2 is leaving the junction. That's what, right? I1 plus I3 plus I4 is equals to I2. Then what, right? I1 plus I3 plus I4 minus I2 is equals to 0. That's why here there is no available of charge at the junction. There is no available of current or charge at the junction, because the current is continuous coming and leaving, coming and leaving, coming and leaving. That's why here there is no accumulation of charge at the junction. That's why here this is the nothing but on the law of conservation of charge, on the law of conservation of charge. So because the charge is 0 there, automatically the charge coming and leaving, coming and leaving. That's why the charge is constant. The amount of charge always should be constant there. And second question, Kirchhoff's second law is based on the law of conservation of. What is Kirchhoff's law? Second law, sum of V is equals to 0. If you can take any loop in that, the amount of, as we are taking like this. So this is the R1 and this is the R2 and this is the battery of EMF E, like this. The algebraic sum of the potentials in a closed loop is 0, that is what we call Kirchhoff's second law. The algebraic sum of potentials in a closed loop is 0. So here the charge is continuously moving. The charge is continuously moving in the loop. That's why here the amount of energy is increase continuously. Amount of energy is increase. So the same constant amount of should be increase. That's why here Kirchhoff's second law is based on the law of conservation of energy is right answer. Because continuation moving of charge, that should be generates the more amount of energy. Every time same type of energy is, for every one rotation the same type of energy is produced or created. That's why the Kirchhoff's second law is what you have to say, that should be based on the law of conservation of energy. B option is the right one, children.
Right.
Dear students, now the problem what I am going to discuss, this is the one of the important model in the Kirchhoff laws. So very important. If you know about it small logic, it will be very easy. See, the question should be like this. The figure shows currents in a part of electric circuit. The current I is. The figure shows currents in a part of electric circuit. The current I is. So children, this is the one circuit, and what you have to find out, the current I is, we have to find out the I value. So this is the circuit what is given: 2 ampere, 2 ampere, 1 ampere, 1.3 ampere and I. So now how we can find out it? And the options are given like this: 1.7 ampere, 3.7 ampere, 1.3 ampere, 1 ampere. So among these four, which is the right one, we have to calculate. So very simple, children. Now it is the one junction, and this is the another junction, and this is the another junction. So what I am saying, this is the junction A, and this is junction B, and this is junction C. Clear? So now we have to apply the Kirchhoff first law. So we have to apply the Kirchhoff first law. Very simple, that one. What it is? Amount of current entry equals to amount of current leaving. So now at junction A, at junction A. What is the current value? Current value is what? Current what it is? 2 ampere plus 2 ampere. 2 enter, 2 enter. That's why what it is? 4 amperes. Clear? So from A to B, there is no another path. Only one single path is there. A to B, only single path is there. Clear? That's why at the junction A, what it is the current? 4 amperes. That's why A to B, 4 amperes current will move. A to B, 4 amperes current will move. Now at the junction B, how much entering here? What we are saying? 4 amperes is entering. 4 ampere is entering. So 4 ampere is entered. In that 1 ampere is moving in this direction. So 1 ampere is moving in this direction. Clear? So 4 is entered, and now what I am saying 1 plus some x, I am saying that. This is the 4 and this is the 1. 4 is entered and 1 ampere is leaving, and this x also leaving. What is that value? 4 plus 4 is equals to amount of current entering equals to amount of current leaving. So what leaving is 1, leaving x also leaving. 1 plus x. From that what, right? X is equals to 4 minus 1, 3 amperes. So here B to C how much moving? And what are the children? So here A to B 4 amperes and B to C, very simple. There is only single path is there. Then 3 ampere is moving from B to C. So 3 ampere is reach the point C or junction C. So how much is entering here? 3 ampere is entering. 3 ampere is entering. And now here I am saying that 1.3 is leaving in this path. And in this path some I am saying now Y is leaving. Clear? So at C, clear? At C, clear children? So at junction C, what you have to write? 3 is entering. This is what children? At junction B. This is at junction B. Clear? At junction C, 3 ampere is entering and 1.3 plus Y leaving. Clear? So here what, right? Y is equals to 3 minus 1.3. So 3 minus 1.3, what it is? 7s. What it is? Simply 2 minus 1 is 1.7. So here Y value is what? 1.7 amperes. Y is what? 1.7 amperes. That Y is nothing but I. That is what here, what you got? 1.7 ampere children. So A option is the correct one. Clear? Among the 4 options, A option is the correct one children. So dear students, so in this way, by using the Kirchhoff law, we can solve this one. Dear students, if you want to get more videos from me, from my channel, you have to encourage me, you have to support me. When you can support me, I will do more videos, and I will do more videos from the different chapters from first year and second year. So I hope you understand my concept. If you can understand this one, like, share, comment the video and subscribe my channel. And if any of your friends are preparing for examination, then inform them about our channel also. Thank you for watching.